Hello and welcome to my science tutorials. In today's video, we want to talk about the discriminant and nature of quadratic equations. Right, so in our previous tutorial, we did look at how to use the quadratic formula to solve quadratic equations. Now, in this video, we want to look at how to determine the nature of a quadratic equation. Now, some quadratic equations do not have real roots. That is, if you solve them, you get complex root or numbers that are difficult for you to simplify. A typical example is this expression x squared minus 2x plus 2 is equal to 0. If you were to solve this equation, you realize that you have the expression x is equal to 2 plus or minus the root of negative 4 on 2. So this expression gives us a complex number or a complex root, and so therefore we say that this particular type of equation does not have real roots. Okay, so it has no real roots. Now, how can we identify that an equation has real root or not? Now, there are other equations that if you solve them, you're going to get the two values of x to be, let's say for instance 5, the other value will also be 5. For this case, we say we have repeated roots. And there are those that you solve, you have x is equal to 1 and then x is equal to, let's say, 4. These are what we call, this type are what we call the real roots. This is what we call the repeated roots, since we have repeated numbers. And the ones that will give us a complex answer, or will be forced to leave the answer in a set format, we say it has a complex root or no real root. Now, how can you identify that an equation has either a complex root, real roots, or repeated root? How can you identify that? So let's look at how we can identify that. Now, we said that our quadratic formula is x is equal to minus b plus or minus the root of b squared minus 4ac all over 2a. Now, the expression under the root sign over here, this expression, which is b squared minus 4ac, this expression is what we call the discriminant. This is the expression that tells us whether a particular quadratic equation is going to have two real roots, repeated root, or no real root, or a complex root. So let's look at the conditions for us to determine whether a quadratic equation has no real root, complex root, or repeated root. Now, the first condition is if the discriminant, that is b squared minus 4ac, is greater than 0 or is positive. If b squared minus 4ac is greater than 0 or is positive, then the equation has two real roots, has two real and distinct roots. Let me put it that way. Two real and distinct roots. That is, the roots are not going to be the same. One answer might be 4, one answer might be 1. They're just going to be different answers. So when b squared minus 4ac is greater than 0 or is positive. Now, if you draw this type of graph, you realize that the parabola for the quadratic equation is in this form. It cuts the x-axis. Now, the values at which it cuts the x-axis over here, these extreme points, are the two real roots that we are talking about. They are the two real and distinct roots. Okay, and that only occurs, you have this type of graph if you have the discriminant, which is b squared minus 4ac, being positive or greater than 0. Now, the second expression is when we have b squared minus 4ac less than 0 or is negative. Okay, so this one means it is negative. When this expression gives you a negative result, then the equation has no real root. The equation has no real roots, or some people will say it has a complex root. Now, this type of graph, if you plot it, you realize that if you have the x-axis, this is your x-axis, and you plot this type of graph, you see that the curve, the parabola, will not cut the x-axis at any point. So for you to get the answer or the x value that make the quadratic equation equal to 0, it has to be a complex number since it has not cut the x-axis. Now the last expression is when we have b squared minus 4ac being equal to 0. Now when it is equal to 0, it means the equation has one repeated root. Repeated root means that if the answer is 4, both answers of x will be 4. If it is 5, it's 5. If it's negative 1, it's negative 1, negative 1. Nothing is going to be different. And if we draw the graph of that, let me draw that over here. You realize that the graph, the parabola, looks something like this. It only touches the x at one point and then goes back up. So this is it. So if it is positive, it cuts the x-axis as 2 points, and that is what we call two real and distinct roots. If it is less than 0 or is negative, it does not cut the x-axis at all, and so forth. It has no real root or it has a complex root. If it is equal to 0, it means that it has one repeated root. Alright, let's go ahead and look at some expressions to actually appreciate what we are talking about. So we have to find the nature, we have to find the value of the discriminant and use it to find the number of real roots for each of the following equations. So we have s squared minus 3x plus 4 is equal to 0. S squared minus 3x minus 4 is equal to 0. We have 3x squared plus 4x plus 1 is equal to 0. And then the last one, IV, is x squared plus 10x plus 25 is equal to 0. Now the question is asking us to find the value of the discriminant and use it to find the number of real roots for each of the following equation. Right, so for us to find the discriminant, we use the expression b squared minus 4ac. So in the first case, this first equation, our a term is 1, which is the coefficient of the x squared term. Our b is negative 3, the coefficient of the x term. And then our c is the constant 4. So if we substitute this into this equation, we are going to have negative 3 squared minus 4 into bracket 1 multiplied by 4. So this becomes negative 3 squared is 9 minus 4 into bracket 4 over here, and this will give me 9 minus 4 multiplied by 4 is 16, and so 9 minus 16 will give me negative 7. Now since this expression or the discriminant is giving me a negative value, it means that b squared minus 4ac is less than 0, and hence this particular equation, the first equation, has no real root. So s squared minus 3x plus 4 is equal to 0 has no real roots, or it has complex roots. It has complex root. It means you're going to be getting a complex number. You will be having a negative under the root sign. Alright, so let's look at the second expression, II. We have s squared minus 3x minus 4 is equal to 0. Alright, so let's look at something. Now, if we look at this equation, our a term is equal to 1, our b is negative 3, our c is negative 4. Right, so let's determine the nature of this particular root. So that would be b squared minus 4ac. That would be negative 3 squared minus 4 multiplied by 1 multiplied by negative 4. So this will give me 9 multiplied by 9 minus 4 multiplied by negative 4, and this will give me 9 plus 16, and this is equal to 25. Now because this is a positive value, okay, it means that the discriminant, which is b squared minus 4ac, is greater than 0, and therefore means that this expression has two real roots. It means that the expression has two real and distinct distinct roots. Don't worry, we'll be looking at this equation. We'll be solving this equation, the first equation. We'll be solving the equation to see whether truly we'll have a complex root or the no real root that we are talking about. Now you can solve this on your own. So let me put asterisk here. You can solve the second expression on your own to see whether you not get two real answers for this particular example. Now let's move on to I. Let me get some space. Or no, let me just continue. All right. So the third expression we have I. We have 3x squared plus 4x plus 1. Okay, so let's determine the nature of the root. So that will be b squared minus 4ac. So this is equal to, our b is positive 4. So we have 4 squared minus 4 into bracket. A is 3 here multiplied by 1. So this will give me 4 squared is 16 minus 4 multiplied by 3 multiplied by 1 will give me 3. So this is 16 minus 12, and this is equal to 4. Okay, we can see that the answer here is positive, and therefore means b squared minus 4ac is greater than 0, and therefore this equation, the equation has two real and distinct roots and distinct roots. Now let's look at the last expression that we have, iv. The last expression that we have is x squared plus 10x plus 25 is equal to 0. As we can see over here, given to us over here, this is the last expression. So let's look at that. So to find the nature of this particular equation, we have b squared minus 4ac, okay, and this is equal to, our b is 10, so we have 10 squared minus 4 into bracket. Our a is 1, our c is 25. So this is equal to, this is equal to 10 squared is 100 minus 4 multiplied by 25 over here. That is 1 multiplied by 25 will give us 25. So we have here 100 minus 4 multiplied by 25 also give us 100, and this is equal to 0. Now the fact that b squared minus 4ac is equal to 0 means the equation has one repeated root, roots. Okay, yes, one repeated root. So I'm going to solve this expression to see whether we are going to have one answer 2 times, and then I'm going to solve this first equation. So the first and then the last equation, I'm going to solve the first one to see if we'll get a complex root like we've said, whether we'll get a complex root like we've said over here. Then I'll solve the last one to see whether we will have repeated roots as we've seen over here. So let's look at that. So the first expression, this is just for verification. We have x squared minus 3x plus 4 is equal to 0. Let's see whether we'll get complex roots after we solve this equation. So we have our a term is 1, our b term is minus 3, our c term is 4. So I'll be using the quadratic formula in this case. So x is equal to minus b plus or minus the root of b squared minus 4ac all over 2a. So it means that I have minus b, which is 3, minus 3 plus or minus the root of minus 3 squared minus 4 into bracket 1 multiplied by 4 all over 2a, and then the a in this case is 1. So my s is equal to negative will give me positive, so I have 3 plus or minus the root of this will give me 9 minus 4 multiplied by 4 will give me 16. So I have 16 here on 2. So this means my x is equal to 3 plus or minus the root of 9 minus 16 will give me 7, which is negative 7 on 2. So my two x values will be 3 plus root negative 7 on 2, and then x will be 3 minus root negative 7 on 2. The further we have a negative number under the root sign will give us a complex value. So if we punch this into the calculator, we'll be getting 3 plus I root 7 something. So that is a complex number, and that was what we found after finding the determinant, the discriminant of the equation. So from the discriminant, we realize that it has no real root, or it has a complex root. And after solving the equation, we realize that that is true, because we are not getting integers or even decimals as our answer. So this is complex roots. Now let's look at the last expression. So the last expression, or the last equation that we solved, was x squared plus 10x plus 25 is equal to 0. And when we solved this expression, we had one repeated root because it was equal to 0, so it will give us repeated root. So we are expecting the same answer twice. All right, so let's go ahead. Our a term here is 1, our b term is 10, our c is 25. So still I'll be using the quadratic formula again. So I have minus b plus or minus the root of b squared minus 4ac all on 2a. So this means my x is equal to minus b, which is 10 here, plus or minus the root of b squared will be 10 squared minus 4 into bracket. My a is 1, my c is 25. All this on 2a, which is 1. So my x is equal to minus 10 plus or minus the root of 10 squared will be 100 minus 4 multiplied by negative 25 will give me negative 100 all on 2. So my x is equal to negative 10 plus or minus the root of 100 minus 100 will give me 0 on 2. So x is equal to root 0 is still 0, so I'm going to have minus 10 plus or minus 0 on 2. So my two x values are minus 10 plus 0 on 2, and then the other x value is minus 10 minus 0 on 2. Now this is minus 10 plus 0 is still minus 10 on 2 will give me minus 5. Minus 10 minus 0 is still minus 10 on 2 will give me negative 5. So we get to realize that we are having two repeated answers. Okay, so we have negative 5, and that is what we mean by one repeated root, because it's the same number that is repeating twice. So we could see that just by using the expression b squared minus 4ac, which we are calling the discriminant, we are able to predict whether the answer will be repeated roots, complex roots, or two real roots. And that, my brothers and sisters, that is what we call a discriminant. This powerful equation is what we are calling the discriminant of a quadratic equation, and this equation helps us to determine the root or the nature of a quadratic equation. So thank you so much for watching, and I will see you in the next video. Bye bye.